To keep a human alive, you need energy. We track it, we burn it, and we consume it in the form of calories. But there is an entirely different class of nutrients that provide zero metabolic energy. They contain no calories. Yet, if you stop consuming them, your biological processes shut down within days. These are minerals. They are inorganic, elemental tools. Because they are elements forged in stars and the Earth's crust, the human body is incapable of manufacturing them on its own. We have to ingest them constantly, because they control our most critical life-sustaining functions. They regulate cellular metabolism, conduct nerve transmissions, and physically maintain our skeletal integrity. Organic macronutrients, like carbohydrates, fats, and proteins, act as the fuel. Minerals operate differently. They do not burn. They are the actual components of the engine itself. Understanding human physiology requires looking past calories. The body is an electrochemical machine, and it relies on a steady stream of external elemental inputs to function. In nutritional science, these elements are divided into two distinct categories based on how the body uses them: major minerals, or macrominerals, and trace minerals, or microminerals. The major minerals include calcium, phosphorus, magnesium, sodium, and potassium. Your body demands these in relatively massive daily quantities to maintain its baseline operations. Trace minerals like iron, zinc, iodine, selenium, and copper are required in daily amounts that are microscopic by comparison. This diagram illustrates the balance of intake. A deficiency in a microscopic trace mineral is as lethal as a major one due to stoichiometric demand, the exact raw material required for a reaction. Macrominerals serve as massive structures, while trace minerals act as precise catalysts. The classification of major versus trace minerals is a strict reflection of physiological mechanics. It is the difference between building the raw infrastructure for a massive electrical grid and providing the precise elemental trigger that initiates the flow. Calcium is the archetypal major mineral. It demands massive daily intake because it carries an enormous physical burden within the body. This split screen shows calcium's dual utility. On the left, it acts as the primary building block, locking together to create dense bones. On the right, it operates as a microsignaler. Every muscle contraction relies on a flood of calcium ions passing through these cellular channels. If you lack this high-volume mineral, the architecture and the signaling both fail. Children experience poor skeletal growth, and adults suffer severe muscle cramps as the signaling pathways misfire. Calcium's massive volume requirement exists because it must act as both the heavy architectural scaffolding and the real-time chemical messenger. This close-up of a pulsating heart muscle, zooming down to the cellular membrane, shows the body's continuous electrical grid in action. Potassium and magnesium have distinct but complementary roles in keeping this network firing. Potassium dictates the fluid balance gradients across your cellular membranes. By actively moving fluid in and out of cells, it controls the electrical charges that regulate your heart rhythm and transmit nerve signals. Magnesium overlaps with this system to regulate baseline blood pressure and facilitate energy production down at the cellular level. We pull these invisible conductors from sources like bananas, potatoes, whole grains, and nuts. When these specific electrical conductors deplete, the electrochemical communication network begins to break down. The clinical symptoms of this breakdown are immediate. You experience systemic fatigue, profound muscle weakness, and irregular heartbeats. Potassium and magnesium are the physiological power lines. Without their constant presence, systemic electrochemical communication immediately misfires. Trace minerals abandon high-volume structural roles entirely. Instead, they act as specific catalysts and transport nodes. This animated structure illustrates hyperspecific organ support. A tiny molecule of iodine locks perfectly into the missing slot of this protein complex, activating synthesis. This tiny trace is a mandatory biochemical bottleneck. Without it, the thyroid cannot synthesize hormone, halting regulation of systemic metabolism. Zinc operates as another highly leveraged catalyst. Its required volume is microscopic, but it is essential for the immune system and for facilitating hundreds of distinct enzyme activities. Because of this high leverage, a zinc deficiency triggers massive systemic breakdowns. Symptoms include hair loss, slow wound healing, and total growth retardation. Trace minerals function as the body's essential enzymatic anchors. Removing just one microscopic component halts entire systemic metabolic pathways. Iron is the ultimate trace transport node, specifically localized within the circulatory system. This diagram shows oxygen delivery mechanics. Iron serves as the core binding site, allowing robust red blood cells to capture oxygen. Look at the degraded cell on the right, representing iron deficiency anemia. Without iron, oxygen transport simply halts, causing chronic fatigue, pale skin, and weakness. Oxygen is the single most vital element for human survival, yet it remains biologically inert without its microscopic iron transport node. Mineral utility is strictly bound by biological tolerances, governed by homeostatic margins. When these margins are breached, the body will take extreme physical measures to correct the imbalance. As seen on the right side of this visualization, a lack of iodine causes a goiter. The body compensates logically for the deficiency. The thyroid gland physically expands in a desperate attempt to capture the missing element. Osteoporosis operates as another strict homeostatic failsafe. To maintain vital electrical signaling levels in the blood, the body cannibalizes its own structural calcium straight from the bones. Pushing past the upper bounds of tolerance is equally destructive. More is not always better. Excessive iron intake overwhelms the body's storage capacity, damaging the liver and the heart. Excess calcium crystallizes into kidney stones and blocks the absorption of other necessary trace minerals. The body will physically dismantle its own architecture to maintain its baseline homeostasis. Optimal biological health exists only in a state of perfect stoichiometric balance. We maintain this highly calibrated inorganic baseline through daily dietary intake, fueling the network with a diverse matrix of whole foods: green leafy vegetables, dairy products, seafood, whole grains, and proteins. Major minerals sustain the body's heavy scaffolding and manage its electrical timing, while trace minerals provide the specific catalytic requirements for respiration and immunity. Calories alone do not power the human body. It is a delicately balanced inorganic machine, reliant on a constant, diverse elemental supply to sustain the mechanics of